So I have only 10 minutes, so let's start immediately with the IOTA simple rules. When you use the IOTA simple rules, there are 5 malignant ultrasound features and 5 benign ultrasound features. You search for these features in your annexal mass and you simply tick them off on a paper form or in an app or simply in your brain if you have a good memory. And if there are only malignant features, the mass is classified as malignant. If you have only benign features, the mass is classified as benign. If there are both malignant and benign features, or if none of the 10 ultrasound features is present, the mass cannot be classified using the simple rules. So these are the 5 malignant ultrasound features: irregular solid tumor, irregular multilocular solid tumor with the largest diameter of at least 100 millimeters, at least 4 papillary projections, ascites, and very rich vascularization on color Doppler. These are the benign ultrasound features: unilocular cyst, smooth multilocular cyst with the largest diameter of less than 100 millimeters. There are small solid components, but the largest diameter of the largest solid component is less than 7 millimeters. Shadowing and no detectable flow on color Doppler. When the simple rules were prospectively validated in at least 10 studies, they were found to be applicable in at least 75% of all annexal masses. So how do we manage the unclassifiable masses? One solution is to classify all unclassifiable masses as malignant. If you do that, the risk that you will misclassify a malignant tumor as benign is minimal. But of course, you will misclassify many benign tumors as malignant. Another solution is to refer the patient to a very experienced ultrasound examiner who will then use pattern recognition to classify the mass. And a third solution could be to apply, for example, the IOTA risk, an IOTA risk calculation model, for example, the simple rules risk calculation model. When you use the simple rules risk calculation model, you enter the 10 ultrasound features in the simple rules into a mathematical model that calculates the individual risk of malignancy for each patient. However, that requires access to a computer. On the other hand, you can read off the individual risk of malignancy for 97% of your patients by using a table like this one, which takes into account the number and type of benign and malignant ultrasound features, and you can read off an approximate individual risk of malignancy for all your patients if you use a simple table like this one, which is based only on the number of benign and malignant ultrasound features, not on the type of ultrasound feature. So let's look at how these tables work. On the x-axis here, you have the malignant ultrasound features, and on the y-axis, you have the benign ultrasound features. There is one table for patients examined in oncology referral centers and another table for patients examined in other types of center. If none of the 10 features is present, and if you work in an oncology center, the risk of malignancy is 48.7%, while if you work in another type of center, the risk of malignancy is 27.5%. If only one malignant ultrasound feature is present, and that malignant ultrasound feature is irregular multilocular solid tumor with the largest diameter of at least 100 millimeters, the risk of malignancy is 71.7% if you work in an oncology center and 50.2% if you work in another type of center. If only one benign feature is present and no malignant feature, and that benign feature is shadowing, The risk of malignancy is 15.2% if you work in an oncology center and 6.7% if you work in another type of center. If only one ultrasound feature is present, no malignant ultrasound feature, and if that ultrasound feature is a unilocular cyst, the risk of malignancy is 3.1% if you work in an oncology center and 1.2% if you work in another type of center. If more than 2 benign ultrasound features are present but no malignant ultrasound feature is present, for example, shadowing, unilocular cyst, no detectable color flow, the risk of malignancy varies from 0.09 to 0.29% if you work in an oncology center, and between less than 0.01% to 0.12% if you work in another type of ultrasound center. Let's look at this simplified tumor, which estimates the individual risk of malignancy in all patients, but gives you only an approximate risk. If there are no malignant ultrasound features, but 3 benign ultrasound features, the risk of malignancy varies from less than 0.01 to 0.29%, and I think it is reasonable to classify such a mass as certainly benign. If there are no malignant ultrasound features and 2 benign ultrasound features, or no malignant ultrasound feature and 1 benign ultrasound feature, and that benign ultrasound feature is a unilocular cyst, the risk of malignancy varies from 0.19% to 3.1%, and it is reasonable to classify such a cyst as benign. If there is no malignant ultrasound feature, but 1 benign ultrasound feature, but that benign ultrasound feature is not a unilocular cyst, but one of the other 4 benign ultrasound features, the risk of malignancy varies from 2.4 to 15.2%, and such a mass could be classified as probably benign. If none of the 10 ultrasound features is present, or if there is an equal number of malignant and benign ultrasound features, or if there is at least 1 malignant ultrasound features, but there are more benign than malignant ultrasound features, the risk of malignancy varies from 1.3% to 78.1%. Such a mass could be classified as possibly malignant. And if there are more malignant than benign ultrasound features, the risk of malignancy varies from 42% to more than 99.9%. And it is reasonable to classify such a mass as malignant. So to sum up, using the simple rules as they were originally intended to be used, we can classify at least 75% of all adnexal masses. When we use the simple rules risk calculation model, we enter the 10 ultrasound features into a mathematical model that calculates the individual risk of malignancy for each patient, but that requires access to a computer. But we can also read off the individual risk of malignancy for 97% of our patients by using this table, which takes into account the number and type of benign and malignant ultrasound features, and we can read off an approximate individual risk of malignancy for all our patients by using this simple table, which takes into account only the number, but not the type, of malignant and benign ultrasound features. Thank you very much for your attention.
Thank you, Lil. Do we have any questions from the audience? No. Lil, do you have your explanation why the acoustic shadows is in about 15% of malignant tumors in oncological centers? If you...
The risk of malignancy, up to 15%.
In tertiary centers, if you have the acoustic shadows.
Yeah. Well, there are some malignancies with calcifications, for example. I think some serous adenocarcinomas, which are low grade.
Exactly.
I think they have calcifications, for example.
Exactly. This
Yes.
is what I wanted pointed out, that really the psammoma bodies are responsible for these calcifications. We see that there is really acoustic shadows, or the tumors which are getting the necrosis with calcification. And that's very important to know that also we have been taught that calcification, the acoustic shadows, is always the sign of benignity. It's not the true, Thank you.